We'll start a timer for 3 minutes.
Sure, 3 minutes. Starting now.
Let's talk about AI. In our modern generation, AI is everywhere. From robotics to facial recognition, autonomous driving, and even patient diagnosis, AI makes our lives better and easier. We also see AI all the time in entertainment, from Joshua in War Games to Jarvis in Iron Man. What we never see though, is how computers actually learn. They call it deep learning. Why is it deep? It's because computers can use deep neural network structures in order to solve tasks. Given a set of input data, these deep neural networks can pass the data through its layers in order to make a prediction. Let's try a simple task. Given 3 numbers, our network's job is to make a prediction of what the 4th number is going to be. So here's what a neural network looks like. The way it makes its prediction is by passing the input data to its network, then, using its weights and biases, calculate the values for the next layer of neurons until it reaches the output layer. The output neuron with highest probability becomes the prediction of our network. Mathematically, we can think of our network as a function computing many dot products between the layers before reaching the final layer. Since the weights and biases are initially assigned at random, the network's prediction at first is going to be fairly inaccurate. Imagine trying to ride a bike for the first time with no previous experience and no time to correct your mistakes. Exactly. The error of our network is calculated as the error of each output probability squared, all added together. We call this the cost function. So, the goal of training our network is to decrease our cost function's value by changing our weights and biases. We call this gradient descent. Imagine you're at the top of a hill and you want to get to the bottom. Each time you take a step, you update your location, and as you get closer to the bottom, you get closer to your end goal. Our cost function is our hill. Each time we adjust our weights, we're taking a step closer to the bottom of the hill, which represents our minimum error. For each step, we first need to find which direction to move in that will decrease the cost function most quickly. We do this by finding the negative gradient of our function, which tells us not only the direction is downhill, but also how steep the descent is. It's as if we were taking all the weights and biases of our network and putting them into a column vector. Our negative gradient would be a separate column vector that tells us how much to nudge our weights and biases in order to decrease the cost function fastest. So our negative gradient is the path we take to get to the bottom of the hill, or our slope towards the minimum of the cost function. So there's all you need to know about gradient descent. Not really. There's still so much more to learn about how a computer can calculate its gradient through backpropagation. But at least you know how a computer can learn through gradient descent and minimizing its cost function. Plus, now you know that computers learn through the way that humans strive to learn every day, and that's by correcting our mistakes. Looks like time's up.